Hello and welcome to another episode of Slam TV. I'm Professor Roger Yang, and today we're going to learn about the matched pairs test. Luckily for you folks at home, we've got a very special guest for you. He's an expert hypothesis test investigator. He can execute tests for the mean even without knowing population standard deviation sigma. He's Professor Jay Cho.
Thank you.
Hey Jay, how's it going?
Pretty good, thanks.
Man, you're looking pretty buff. Have you been working out, special diet or something?
Actually, I'm on the keto diet. Remember you mentioned it last time? We were talking about estimating population proportion.
Oh yeah, that's when we were checking whether people wash their hands or not after using the restroom.
Exactly. Ever since you mentioned it, I noticed the ads everywhere. So I decided to try it,
Do you think the ad is true? Do you think the keto diet really works?
I don't know.
If only there was a statistical technique we could use to test the claim that people gain over 10 pounds on the keto diet.
I know. Wait, I do know. I learned how to test this type of claim in my hypothesis test investigator training program.
Okay, cool. So what kind of test is this?
Well, let's look at the ad. Basically, it says people could gain on average 10 pounds on this diet, right? Does this sound like it's a proportion or it sounds like it's a mean?
Well, we're measuring the amount of weight that they lost, and we're trying to see if that is over 10 pounds. So since we're measuring the amount of something, to me it seems like we're doing a test for the mean. Actually, didn't we do a test for the mean in a previous episode when we tested the claim students sleep less than 7 hours a night?
Oh yeah. We're measuring the number of hours they slept.
Oh, we're measuring the amount of time they slept, not whether they slept 7 hours or not.
Exactly, so we have a quantitative data set.
Oh, and it's not categorical.
Exactly, that's why we're not doing proportion, but the mean.
Good times. Hey, in that episode, our claim was mu less than 7.
Here, we're going to use mu d instead of mu.
Why do we use mu d?
Well, mu is for population mean, which is good, but d is for the differences. Here, I'm looking at my weight before the keto diet and after the keto diet.
Oh, before versus after. Didn't you give this type of test a special name?
Right, this is a classic example of matched pairs test. Matched pair data comes in ordered pairs. We collect pair data. In this case, someone's weight before and after going on the keto diet.
What do you do after you have all of this data?
Well, in order to calculate the difference, we need to subtract those two numbers.
Does it matter which order we subtract in?
Yep, it always matters which order you subtract.
Oh yeah, that's right, because 3 minus 1 is 2, but 1 minus 3 is negative 2.
Exactly. The order we subtract will determine the null hypothesis.
What order do you think we should subtract in our case?
Let's do after minus before.
Okay. So our matched pairs data comes in ordered pairs. We will use the variable d to represent the weight gain for each person in our sample. We find d by taking the after weight and subtracting the before weight.
So if the entire world was on keto diet, we look at their weight gain after minus before, and if we look at the average of all these weight gains, there'll be a population mean mu d.
Oh, that's why you call it mu d.
Exactly. Now let's go back to our example and see if we can translate our claim into mathematical statement.
Okay. So our claim is gain over 10 pounds in a week by going on the keto diet. Since we're doing after minus before, if I weighed 150 pounds after the keto diet and 140 pounds before, is our claim mu d equal to positive 10 since 150 minus 140 is equal to 10?
Well, you subtract it and get positive 10. That part is great. But the claim is saying that you gain more than 10 pounds in a week. This means the average gain should be bigger than 10.
Oh, so you're saying mu d is greater than 10.
That's right. You see how the order we subtract these two numbers will make a difference in our mathematical statement?
Not really.
Really? Let's try to subtract in different order. What if we did before minus after?
Okay, so then d is going to equal to before minus after. What's the big deal?
Well, what would d be if you gained 10 pounds?
Well, before I weighed 140 pounds, and after I weighed 150 pounds, then before minus after is equal to -10.
That'll completely change our mathematical statement. Gaining more weight will give you more negative number.
That seems really weird to me to have weight gain be a negative number.
Right? So the point here is the way you subtract, the order that we subtract these numbers matters.
Oh, I can see that, because if you change the order you subtract in, you pick up a negative.
Exactly. Let's go back to our example. Let's kind of stick to how we set up before, after minus before.
Okay.
What would the null and alternative hypotheses be?
Well, since the math statement version of our claim has a greater than symbol, it must be the alternative hypothesis.
Okay, how about the null?
The null and alternative need to be opposites, and the opposite of greater than is less than or equal to. So for us, mu d is less than or equal to 10.
Okay, and which is the original claim?
The original claim is going to be the alternative hypothesis.
Good job, Roger.
Thanks. Man, we could test this claim if only we had matched pairs data.
I actually do have this data.
You do?
Uh-huh. I'm a part of the online group called Kilos for Kids.
Kilos for kids?
1877 kilos for kids. 1877 kilos for kids. 1877 kilos for kids. Go eat your carbs today.
What is this? You gain weight for charity?
Yeah, it gives you extra motivation and it helps the kids. It's an active online community. You post your weight before and after. You ask for donation based on your weight gain.
Wow, Jay, that's a really noble cause.
Exactly. Would you like to donate today?
Oh,
It helps the children.
yeah, I think I left my wallet at home.
How convenient. Oh. Anyways, I do have the sample data we need.
Great. Why don't we take a look at the sample statistics from your data?
Well, we had a sample of 25 people and get the sample mean X bar. Second line X bar is 10.5 and sample standard deviation of SD 1.3.
Why do you call it X bar D? Is that like the sample mean X bar?
Right? X bar is for the sample mean, but the way we got the mean was by looking at the difference. That's why we have D there, indicating that we got that from difference of two weights.
Oh, okay, great. So what's the population standard deviation? We need that in order to do the hypothesis test, right?
Actually, here we don't have a population standard deviation.
What? Are we totally screwed?
Don't freak out, Roger. Remember Norm's grad student?
Oh yeah, student T.
When we don't have population standard deviation, we can use student T distribution to do our testing.
Okay, great. So our random variable is X bar D, and our distribution is the student T distribution. Oh, does the student T distribution have a special notation like the normal and binomial distributions?
Yes, the notation used for student T distribution is TDF.
What did the DF stand for again?
Degrees of freedom? It's just an n-1 in our case. Since our sample size n is 25, the degrees of freedom is 25 minus 1, which is 24.
I see. So the next step is for us to use our calculator to calculate the p-value, right?
Exactly. What calculated function do you think we should use here?
Well, last time when we ran a hypothesis test for the mean, we used a z-test.
Huh. But z is for normal distribution because we had a population standard deviation sigma.
Oh, right. This time we don't know what sigma is, so we have to use the student T distribution.
Exactly. That's why we're going to use t-test.
Is the only time we use t-test when we have matched pairs?
No. When we are dealing with population mean, but we do not know the population standard deviation sigma, that's when we use the t-test. In matched pairs case, our sample data happen to be just the differences.
Oh, so you're saying I could have tested a claim like students sleep less than 7 hours a night, even if I didn't know population standard deviation sigma.
Exactly, we could have just run the t-test. Anyways, let's go back to our example and plug in our numbers. First line, mu naught is 10. That comes from null hypothesis. Second line, x bar is 10.5. That's our sample mean. After that is sample standard deviation, S is 1.3. N is our sample size, 25. The last line comes from our alternative hypothesis. Mu is greater than mu naught.
And hitting calculate, we get the first line is just restating our alternative hypothesis. The second line is our test statistic, t equal to 1.923. And finally, we get a p-value of 0.0332.
And how did you draw the p-value graph?
Well, since we're dealing with the student t distribution, I'm going to draw a curve that's shorter and wider than the normal distribution. I label the test statistic t equal to 1.923, and I shade to the right since the alternative hypothesis is greater than.
So what's the decision then?
Well, we can't make a decision until we know what the significance level is.
Well, when the significance level alpha is not given, we're going to just assume that it's 0.05.
Oh, okay. So to make our decision, we need to compare the p-value to the significance level. In our case, our p-value was 0.0332, which is less than the significance level of 0.05.
Okay.
That means in our case, our decision is that we reject H naught.
Oh, I get it. And how would you tie that to our conclusion?
Well, in this case, our original claim corresponded to the alternative hypothesis.
Okay.
So this means we're in the support the original claim or fail to support original claim scenario.
Okay.
And our decision was that we rejected H naught, which means we support the opposite thing. So in our case, we're supporting the original claim.
Huh. You mean the data suggests that we support the original claim that on average, people gain more than 10 pounds on the keto diet?
Woohoo! I think we did it.
That's great. Well, why don't you summarize what we learned today for our viewers?
To summarize, we learned about two different things today. The first thing we learned about is the t-test. The t-test allows us to conduct hypothesis tests for the mean even when we don't know the population standard deviation sigma. Instead of using the normal distribution, we use the student t distribution. The second thing that we learned was the matched pairs test. The matched pairs test is really just a special case of the t-test. It's really a test on the differences between the before scores and the after scores. Because the matched pairs situation comes up so often, we have a special notation for some of the things that we use. Mu d is the population mean of all the differences. X bar d is the sample mean of all the differences. And SD would be the sample standard deviation of the differences. This basically summarizes what we've learned this episode. Are you surprised the sample data supported the claim that people gain over 10 pounds using the keto diet?
Nope. I already gained 7 pounds.
You're going to need to buy new clothes or something.
I know. I need to get a new shirt, new socks, new hats, new wristband. So much to buy.
Yeah. Aren't you worried about gaining fat instead of lean muscle mass?
Not really. Have I ever told you about my childhood dream job?
You mean dream career?
Oh yeah. My childhood dream career was to be a sumo wrestler.